Chapter looks at the installation required practical for AQA Science. In this investigation, you are asked to investigate the effectiveness of different materials as thermal insulators and factors that may affect the thermal insulation of properties of the material. You'll need to measure the rate of cooling of a beaker of hot water when insulated with different materials, and then plot a cooling curve for each type of insulator. So the first thing that we really need to think about before approaching this practical is how heat is lost and how insulation works. I'm not going to go and dwell on convection, conduction and radiation, but you will need to keep referring back to conduction, convection and radiation when you go and do any descriptions or conclusions. So, in terms of heat loss, there are various ways that we can insulate against it. So, we can think about heat loss through windows, which can be reduced by double glazing. Right? This is because there's a vacuum between the two planes of glass, or there's an air gap. So, trapped air is a good insulator because it stops conduction. When going through and thinking about the types of insulators you'll need to be using, think about the amount of air that's being trapped and how easy it is for that air to go and move out by convection. Some will be easier than others. So the table that you'll need to draw will look something like this. So you'll have no insulation, which will be your control, the bubble wrap, newspaper, polystyrene, sawdust, or any other different types of insulation that you might have handy. Some people have some people have others. Right, you need to go and make at least 5 readings so you can then go and plot a graph. Remember that your independent variable is the type of insulation, the dependent variable is the temperature of water, and the control variable is probably the volume of water that you're putting in or the size of beaker that you're using. Right, the following short clip goes and just shows a small part of the practical running, just so you can see how the results come up when using data loggers. So, once you've gone and you've got your results, you can go and plot them. Right, this photo is a little bit hazy, however, we'll talk about it in a minute. The starting temperature for each of the 4 types of insulator that we used all started off at about 74 degrees. The one that's got the pink went down after 5 minutes to 69.5 degrees, the blue 68, the green about 64, and unfortunately we can't make the last one out. After 10 minutes, the first reading, so the purple one on the left hand side, had gone down to 64.3. The following one had gone to 63.2, the green to 58.5, and finally the one on the far right hand side 63.4. After 15 minutes, the one on the left hand side had gone down to 58.5, followed by the one next to it 57.2, 51.9 and 57.6. Now final reading after 20 minutes was the red one went down to 49.9, the blue to 48.6, the green 43.1 and the purple one to 49.5. I would advise go get some results that go and correspond to the types of insulation that you've used. Well, hopefully this kind of shows you how the temperatures are decreasing, and decreasing differently depending on the different types of insulation. So once you've gone and you've got all of your results, you'll need to go and plot some cooling curves. So a heating curve or a cooling curve is a graph showing the temperature of a substance plotted against the amount of energy it has absorbed or has lost. Right, make sure when we're drawing this, your horizontal line across your graph paper needs to be the time taken. Along the vertical line needs to be the temperature of each of the types of insulators. Remember that you need to go and put your points on your axes at equal points, so it couldn't go 1, 2, 15, 20, 21, etc. It's have to go 1, 2, 3, 4. Make sure that when you're going on, you then go and label both axes. Right, physically plotting points, make sure that when you find where the points are, you put a clear X, and then for each of the types of insulators, you go and put a smooth line of best fit. You should come out with a graph that looks something like this. Right, hopefully this video has gone and outlined what you need to know for this required practical, and good luck.